This is one example on how to graph rational functions. Step 1 to graphing a rational function is finding the asymptote. An asymptote is a line that a graph approaches but never reaches. So this is an asymptote. Your graph never really actually meets it, but it gets really close to it. Okay, so step 1 to graphing a rational function is you want to find the asymptotes. So for y equals negative x over x minus 1 squared, you want to find the vertical asymptote. To find the vertical asymptote, you find the zeros of the denominator. So for x minus 1 squared, you want to factor it out. X minus 1 times x minus 1. And set them both equal to 0, and then to get x by itself, you add 1 to the other side, and you get x equals 1. That's your vertical asymptote. Okay. Step 2 for graphing rational functions is finding the horizontal asymptote. So to find the horizontal, you want to look at the degree of the denominator and the degree of the numerator. The degree of the denominator for this equation is 2, and the degree for the numerator is 1. So if the degree of the numerator is greater than the degree of the denominator, there is no asymptote. If the degree of the denominator is greater than the numerator, then the asymptote is y equals 0. If the degrees are equal, then y equals the leading coefficient numerator over leading coefficient denominator. For this one, the denominator asymptote is greater than the numerator, so y equals 0. So now we move on to actually graphing the equation, and first you want to mark your asymptote. So we knew that x equals 1 and y equals 0. So your asymptotes would be that on the graph. So x equals 1 you want to mark off as your asymptote using dotted lines. So your graph will never ever touch these lines but get very close to it. And then y equals 0. Okay, so now you want to plug in points on either side of the asymptote. So x equals 1. So first I started off before the asymptote. So you want to get very close. I use 0.5 half to get close to the asymptote 1. And then you get your x and y's and you start plotting them. But you never want to get so close that it looks like you're touching the asymptote. You want to get barely by it. Okay. So points close to the asymptote, like 1.5, 1.1, anything that will get you close to the asymptote but not 1. And when you graph your curves, you want to make sure that you put arrows on both sides because they never end. They keep continuing, but again, they'll never reach our asymptote 1, or they'll never reach the asymptote 0. They'll keep on continuing close to it, but never fully reaching it.
This is another example on how to graph rational functions. So as you learned in the example before, the first thing we have to do is we get the equation that you first start off with, and you have to factor the denominator. So after we factor this, we've gotten x plus 2 and x minus 2. So we have that equal to 0. So it would be x plus 2 equals 0, and x minus 2 equals 0, and you would end up with x equals plus or minus 2. So those are the asymptotes that you would line up onto your graph. So you would use dashed lines to represent that, and you will never be touching these with the curve of the points that you end up with. You will just be skimming across but never really touching. And since the denominator degree is greater than the numerators, the horizontal asymptote is 0. As we see here, it has a degree of 1, an imaginary degree of 1, and this has a degree of 2. Since this degree is bigger than the other one, the horizontal asymptote will be 0. And here you can see that I've gotten points and I've plugged them into the original equation, and I've gotten these points. And we have to remember that the positive x values will be to the right of the asymptote that says x equals 2, and the negative x values will be to the left of the asymptote x equals negative 2. So you plug them into the graph, and then you make the curve, and make sure to extend your ends. And then we do the same thing, but this time we need a parabola at the bottom. So we would have the vertex of 0, 1/2, negative 1/2, and we would plug in the points, and we would get a slight curve, and we would extend that as well, and you would end up with the graph of y equals 2 over x squared minus 4.